We have these three mixtures in front of us. There is salt water, there is chalk in water, and there is milk. Can you categorize these mixtures according to what you observe, what you see? Well, you might be thinking we can categorize them as heterogeneous and homogeneous mixtures. Now, what if I tell you that the first mixture, well, this one is homogeneous, salt is easily dissolved in water, and the other two are actually heterogeneous mixtures. We can see why chalk would be a heterogeneous mixture, but why is milk a heterogeneous mixture? We will talk about all of this, and in doing so, we will understand the differences between a solution, a suspension, and a colloid. So to begin with, let's dive deep into a solution. Alright, to begin with, we will talk about solutions, and as an example, we will take salt water. Now, the first characteristic of a solution is that it's a homogeneous mixture, which also means that the solute, in this case the salt, it's evenly or uniformly distributed across the body of the water. It is dissolved in water. And what does that really mean though? So let's think about it. So let's say there are these water molecules or ions. Each dot represents a water molecule, right? H2O molecule. So when we say that salt is dissolved in water, it means that each individual particle or ion of a salt, it is spread out uniformly across the body of the water. So this is one individual particle or ion of a salt, one individual particle of, let's say, NaCl, right? Each particle of NaCl, of salt, is taking up the space between the water particles. So that is what it means when we say something is dissolved in something else, in this case salt into water. So this is the first characteristic of solutions. The other is, we can say that the particle size, in this case the particles that are dissolved, they are extremely small. So this one individual particle, it's of the order of 0.01 to 1 nanometers. Now, third characteristic is that particles don't settle down. If you have a salt water solution and you let it be for some time, you will not see salt settling down near the bottom of the beaker, which means that you cannot really separate salt from water by filtration. If it is not settling down, then how can you separate these two from each other? So it can't be separated by filtration. One more characteristic is that the particles don't scatter light. What does this mean? So let's say if we have a laser and we strike laser onto this glass full of salt water solution, you will see the laser light striking the glass at this point. You will see it coming out from this point, but you will not see the path of the light inside the salt water solution. And that is what it means when we say that particles don't scatter light. That is, you will learn about this in detail in other videos. So when there is a particle, let's show a particle with some other color. So let's say if there is a particle right over here and there is a laser light coming onto it. The particles are so small. These particles are so small. They are so small in size that this light just keeps on going. It does not get scattered. And we will see when does it get scattered under suspensions and colloids. But in this case, it is not scattering. So this was all about solutions. Now let's move on to suspension. Alright, so for suspensions, we have the mixture of chalk and water. The first characteristic of this mixture is that it is a heterogeneous mixture, which means that the particles are not uniformly distributed across water. You can easily look at them even. So from this very property, you can say that when you just let the mixture be for some time, these chalk particles will settle down near the bottom of the glass, and you can also separate them by filtration, right? So some other properties that we can attribute to suspensions, one of them is that particle size is greater than 1000 nanometers. That particles separate on standing. This chalk will settle down, which means you can separate them by filtration. And finally, we can say that particles scatter light, which means if there is a particle like this, so the particle size is quite high in this one, right? If there's a particle size like this and there is light coming in, striking the particle, it scatters in all the directions, right? So there could be some light that is coming to you, and these could be those rays coming into your eyes. So what that means is, if you have a laser light striking this mixture, then you can see the path of the light inside that mixture. Alright, now let's move on to colloids. So here we have colloid. This is milk. Now the first property is that it is a heterogeneous mixture. Now, even though the particles in a colloid, they are uniformly distributed, so let me write that they are uniformly distributed, even then this is a heterogeneous mixture. Even then this is a heterogeneous mixture. And let's see why that is. So if you think about the size of the particle in a colloid, that is between the size of the particle in a solution and a suspension. This is 1 to 1000 nanometers. It was much smaller in a solution and it was greater than 1000 nanometers for a suspension. The particle size is in between. So what that means is, we say that a mixture is homogeneous when the solute is uniformly distributed. So that means if there are solvent particles like this, let's say if this is water, then each and every individual solute particle will take some space in between these solvent particles. So if there is salt dissolved in water, you will have one individual salt ion or particle taking up the space in between these water molecules. That is what it means when we say something is dissolved, right? In a suspension, something is different. So in a suspension, if there are these water molecules, then chalk that we took, the example of chalk, you will have clumps of chalk, but they're not taking up the space in between the water molecules. You have like a clump of molecules, not an individual molecule, right? And for a colloid, things lie somewhere in between. So the particles are not as large as the particles in a suspension, but also not as small as the particles in a solution. In a colloid, if you have these water, something like this, solvent molecules or water molecule, then the particles are not individually taking up space in between these solvent molecules, but also they are not as large as the suspension particles. These are still very tiny blobs or clumps of particles, but they are not entirely dissolved in the solvent, right? For something to be dissolved, individual ions or particles need to take up the space in between the solvent particles. That is not the case with colloids. Neither is that the case with suspensions. But because the particles are much smaller than the particles in a suspension, these particles remain suspended. The colloid particles, they remain suspended and uniformly distributed. So in the case of milk, you have these liquid droplets of fat. I'm showing fat with blue droplets. You have these liquid droplets of fat uniformly distributed across the body of the milk, but they aren't dissolved. They are just suspended in milk. So we can also say that particles, they don't separate on standing. They remain suspended, which means they cannot be separated by filtration, right? And the last characteristic of a colloid is that particles, they do scatter light, and in fact that is called a Tyndall effect. So when you strike a laser across the two ends of a glass, you will see the path of the laser light through milk. That is because when light strikes a particle of a colloid, it scatters the light in all the directions. This effect is called a Tyndall effect. Alright, so these were the differences between suspensions, colloids and solutions.